Yo, what's up, man? Yo, this is your video for Unit 11 test. Hopefully it helps, man. Let's go ahead and get started. Hey, yo, please, make sure you like the video and subscribe. Okay? All right, man. First, we're going to talk about all the sampling, the 6 types of samplings. All right, here they go. Simple, random, stratified, cluster, systematic, convenience, and self-selected. All right. Simple, random. I'm just going to do some quick examples. All right, it's on you to make sure you look at your 11.1 notes. All right, to look more in detail on these. But simple, random. All right, simple, random is if you had a list of everybody, every student in Archer, and you picked 100 random. All right, that's simple, random. Every student. All right, it's simple random. All right, stratified. All right, the thing with stratified, I want you to remember is you got to put them in groups. All right, and then after you pick the groups, you pick the same number randomly from each group. All right, so if I put y'all in 9th, 10th, 11th, and 12th, all right, those are your groups, 9th, 10th, 11th, and 12th. And then I'm going to pick 5 from this one, 5 from this one, 5 from this one, 5 from this one. All right, that's stratified, okay? I'm going to pick 5 from each group. It's not just putting them in groups. All right, but you're picking randomly from every group. Cluster, all right, cluster is, again, putting them in groups, all right? But again, if I have 9th, 10th, 11th, and 12th, all right, I pick the whole group. So tomorrow, all 11th graders are taking this Algebra 2 test. I picked the whole group. They're going to do the survey. Y'all got it? The whole entire group. Systematic is a system. All right, every 7th. All right, every 7th person that walks through the door, okay? Convenient would be if every student in my classroom, just because they're here, all right, or a rally, they're easy to get to, okay? They're easy to get to. So I can just give them the survey because they're here, all right? And self-selected, all right, self-selected would be, again, you chose. You chose to reply to the email. You chose to call in and give your opinion. You chose to call the number on the back of the Burger King receipt and give the survey because you was like, hey, they're giving away a free Whopper if I call the back of the receipt. All right. So anyway, right here, man, we're going to what type of the above sampling method describes it. All right, this first one right here, man, a traveler is writing a magazine. A writer for a traveler magazine wants to learn tourist opinions. All right. Anyway, man, she decides to visit a different tourist attraction every day for a week. All right. She will have the magazine intern, the travelers, intern people who are traveling. All right. To see each attraction. So look, this is convenient. All right. And I'm going to tell you why. All right. It's convenient because, listen, they're there. All right. They're there and they just happen to be there. So it's a convenience for you, all right, to just ask them questions. That makes sense? All right, I hope so. All right, convenience. All right, the next one, man, a survey of students' favorite teachers being conducted for every 4th student, all right, at Archer's High School is asked, all right, every 4th student. Well, that is stratified. I'm sorry, not stratified. That's systematic, guys. Sorry. All right, that's systematic. All right. For the next one, a startup company wants to do a survey to find out if people will purchase its product. Company employees conduct the survey by asking 50 of their friends. Again, man, that's convenient. All right. I'm asking my friends. All right. I'm sure I got access to my friends. All right. Next we have Publix wants to know who the customers think is the best cashier. Customers can vote on the Publix website. Man, that's definitely self-selected. All right, because again, man, when I go shopping, I don't care, man. As long as you ain't tripping with my money, I'm good, man. All right, and I promise you, I'm probably not gonna take the time out to do this survey. All right, if I did, that means I probably really, really, really hated you. You know what I'm saying? Or really, really, really enjoyed your time. All right. Other than that, I doubt it, man. All right. A homecoming committee wants to know which theme the majority of students at Archer prefer. They randomly chose 25 freshmen, 25 sophomores, 25 juniors, 25 seniors. Again, they're put in the groups, freshmen, sophomore, juniors, seniors. And then you choose the same number from every group, guys. That's not clustered. All right, that's stratified. All right, yes, they're in groups, but you choose randomly from each group. All right. A principal at Archer wants to know how teachers feel about working at Archer. All right, so he generates a list of 25 teachers, all right, from a database that has all teachers, everybody's included, and that is simple random. All right, simple random, okay. All right, let's go ahead and dug into this problem right here. Number 3, man, is the margin of error. All right, and it says, hold on one second. Let me zoom out. I need more space. All right. This problem says a community association surveys its members about who would like to have the next chairman. Have as the next chairman, Hickory or Washington. They surveyed 36% said Hickory. All right, 36% said Hickory. All right, and 64% said Washington. All right, so the margin of error is 9, guys. So with a margin of error, first of all, you got to do plus or minus. Okay, plus or minus 9. Let me do that. I'm going to use a highlighter. There we go, plus or minus 9. So here we go, man. Let's find the margin of error. Well, we're going to take 36. We're going to subtract 9. All right, 36 minus 9 is going to give us 27. All right, and we're going to add 9. All right, and 36 plus 9 is going to be 45. All right, so this is his interval. All right, make sure you do the intervals, guys. All right, for 64 right here, all right, we're going to do their intervals, and then we're going to get 64 minus 9 is 55. All right, and 64 plus 9 is going to be 73. All right, this is Washington intervals, okay? So now the question is, determine if the survey clearly projects a winner. Does it project a winner? All right, and explain your response. Explain your response. All right, and the answer is yes. All right, yes, and why? All right, why? Because there is no, and a key word I'm going to put right here in red, overlap. All right, there's no overlap, guys. Don't forget that word. You need to mention that in your answer tomorrow. All right, you need to say yes because there's no overlap or no because there's overlap. All right, there's no overlap. All right, 27 to 45. All right, none of those numbers in that range is in this range, 55 to 73. All right. All right, this next problem right here. The school district decided to poll all the English classes in the district about the summer reading list. 52% said that the list was not diverse enough. 48% said the list was fine. The survey margin of error is 2%. All right, does this clearly project the winner? All right, so again, let's go ahead. Let me make this bigger because I need more space. This time I need space. All right, so again, the first one is 48%. All right, so if I do the margin of error, all right, 48, the margin of error is 2%. So 48 plus 2 is going to be what? 48 minus 2 is 46. All right, and 48 plus 2 is 50. All right, there's his interval. All right, and then for the other one, it was 52%. All right, let me see. Yep, 52%. All right. All right, and the margin of error here is 50 to 54%. All right, so now, again, does it contain a winner? Well, look at this math right here. Look at the intervals. 46 to 50, 50 to 54. Uh-oh. All right, I see the same thing. All right, it contains the same thing. But not just because I can visibly see these. If these numbers are in the same range of these numbers, all right, then there's overlap. All right, so is there a clear winner? All right, is there a clear winner? No, because there is, in red, keyword overlap. All right, overlap. All right, that's an E, guys. It's a sloppy E, but it's an E. All right, overlap. All right. All right, man. So it does not clearly, guys, all right, give you a winner. Okay, let's look at number 5 down here. Oh man, this is directly from 11.2 notes right here. Directly from 11.2, 100% from 11.2. All right, so familiarize yourself with this. All right here, man. One standard deviation will always have 68%, guys. That will never change. 2 standard deviations will always have, let's see, 95%. And 3 standard deviations will always have 99.7%. All right, those won't change, okay? All right, so let's go and look at this first example. This first example, if the data set of a mean is 55 and the standard deviation is 9, what interval does 68% of the data in line of the data lie in, 68% of the data lie in. I have to go read the paper, sorry. What interval is in 95% and what interval is in 99.7%? All right, check this out. Let me do this for you on another sheet of paper. All right, let's go right here. I was working on this earlier so y'all can see this, okay? All right, we said the mean was, first of all, you got to draw a bell curve for that problem. All right, you have to draw a bell curve. All right, and label it like so. Don't look at all this stuff down here. It's irrelevant. All right, in fact. All right, so I cleared everything off so you guys can see what I'm talking about here. All right, so again, the mean is 55. All right, that should be 55, man. Sorry about that. All right, the mean is 55 and the standard deviation is 9. All right, so let's go ahead and look at this. The mean is 55. You guys know this middle line right here is mu, all right, or the mean, 55. All right, and then the standard deviation is 9. All right. All right, and standard deviation is 9. So I'm going to go 55 plus 9. All right, and 55 plus 9 is going to give me what, guys? 64. All right, and then I'm going to add, all right, and that's 73. And then I'm going to add it one more time and get 82. All right, now on the other side, I'm going to go 55 minus 9. All right, and that gives me 46. All right, and then subtract 9 again, you're going to get 37, and then you get 28. All right, so every one of these lines represent a standard deviation. 1 standard deviation, 2 standard deviations, 3 standard deviations. All right, 1 standard deviation, 2 standard deviations, 3 standard deviations. All right, but anyway, remember, guys, the chart you just made, all right, where it was 68% is 1 standard deviation. So the problem says, let me go back to it so you can see it. All right, what interval does 68% of the data lie in? All right, so here you go. I'm gonna show you. All right, remember, first of all, 34 plus 34 is 68. All right, but the easiest way to know is just 1 standard deviation. 1 standard deviation from here to here, because there's the mean. 1 standard deviation. Here's the mean. 1 standard deviation. So that range is 68%. All right, so for the 68%, what are the intervals? All right, what are the intervals? From here to here. 46% or 46 to 64. All right, 64. All right, and then the next one says 95%. Well, remember, 2 standard deviations is 95%. All right, from the mean. So again, 1, 2, 1, 2. All right, and that is 95%. All right, well, here we go. I got 37 to 73. So for 95%, 37 to 73. All right, and then 99.7% is 3 standard deviations from the mean. 1, 2, 3, 1, 2, 3. All right, 99.7%. All right, and that is going to be, what do we get right there? 28 to 82%. All right, you're going to have a question like that on the test, so make sure you know. It won't be all three. It'll be one of the three. What's 68, what's 95, or what's 99.7. All right, so make sure you put your mean and take your standard deviation and add it and subtract it, okay? All right, so these are the answers to that one problem. I just don't have a lot of space to write, so I'm not going to write it all right here, okay? I'm going to go ahead and go to the next one now. And for this next problem, we got to put all our information on here. All right. Actually, you know what? Listen, I'm going to do, let me use the same one. I'm going to use the same one because that'll give us more space. All right, so let me clear this off. All right. So in this problem here, all right, we're faced with a situation to where the mean, all right, let me go back to the word problem. The mean is 140. All right, and the standard deviation is 27. Yep, 27. All right, so let's go back over here. The mean is 140. All right, and the standard deviation is 27. All right, so if I add 27 to 140, all right, I'm going to get 187. Excuse me, 167. All right, then I'm going to get 199. All right, and then I'm going to get 221. All right, wait, yeah. Wait a minute, I caught a mistake. That's not 199. 167 and 194. All right. All right, over here. All right, I'm going to get 113. And 86 and 59. Okay, so there we go right there. All right, this is our actual scale. All right, so bear with me. All right, guys, so look, I went ahead and took the one we just made and moved it over here. All right, so we can use it. All right, now the first number right here, the first problem. All right, we're going to do it like this. All right. And all this can be done in your calculator too. I'm going to show you. As long as you know these numbers right here, you can do this in the calculator. All right. So y'all see how this is two. Here's mu. All right. This says x is greater than basically 2 standard deviations. All right. So 1, 2. Here's 2 standard deviations. All right. So we're saying x is greater than 194. All right. So what that means is this is its minimum. All right, this is the minimum. All right, so if I go to the calculator, all right, and I go second, VARS, normal CDF, all right, then my minimum is 194. All right, my max, pick a number that's significantly higher, like 1,000, all right, 10,000, that's fine. We said the mean was 140. And the standard deviation was 27. All right. Make sure you have the commas right here, guys. All right. The calculator may be different. All right. But anyway, hit enter. All right. There's our probability right there. All right. 0.0228. All right. 0.0228. All right. So back to our. Because again, we're looking for the probability. So the probability is going to be 0.0228. All right, for part A. All right, part B. All right, we have the probability that that our x is less than 3 standard deviations. All right, minus 3 standard deviations. So here's mu. 1, 2, 3. Here's minus 3 standard deviations. I was looking at that one, right? So that's 59. So we're saying less than this. So that means less than 59, which means 59 is the upper bound. I don't know if you guys remember, but when you have normal CDF, all right, you have lower bound, upper bound, mu, and sigma, your standard deviation, okay? That's how it goes in your calculator. So 59 is our upper bound. So I'm going to go back to our calculator. All right. And we're going to go second VARS. All right. And the minimum, we'll pick something significantly less. All right. And then, I know some of you guys went, why negative 10,000? Yo, just pick a number. You pick the number. You are free right here. Pick a number that is significantly less than 59. Because remember, 59, x is less than 59. So 59 is the upper bound. All right. And again, mu is 140 and sigma is 27. All right. So you got 0.00134. All right. My students, I always tell my students, yo, we're going to go 5 decimal places and use that to round the fourth. Well, 4 doesn't round 3, so I got 0.0013. All right, 0.0013. All right, so here we got 0.0. Oops, put that back. 0.0013. All right. Now, this one right here, we want the probability that x is between 1 standard deviation, like so. Here's mu. There's 1 standard deviation right here, this line. All right, at 167, and 3 standard deviations. All right, 1 standard deviation and 3 standard deviations. So again, mu, 1, 2, 3. Here's 3 standard deviations. So I got an interval right here. All right, so this is going to be your lower bound, and this is going to be your upper bound. All right, lower bound, upper bound. So 167 and 221. So back to my calculator. I go second, VARS, normal CDF. All right, and I forgot what I said. 167. 167 is my lower bound. 221 is my upper bound. And all this doesn't change. All right. All this doesn't change. But anyway, hit enter again. Boom. All right. 0.1573. 0.1573. 0.1573. All right. And then right here again, one more time, we got boundaries. So we have minus 1 standard deviation. Here's mu, minus 1 standard deviation. All right, and then you have plus 2 standard deviations. So here's mu, 1, 2. Here's 2 standard deviations, right? So our lower bound, all right, is, here you go, let me do this. Our lower bound is 113 to 194. All right, so when you do that, you're going to get, there we go, calculator. Second, VARS, normal CDF. All right, and we said we're going to go between 113 and 194. And the other stuff doesn't change. So we get, well, I did it a bunch. All right, there we go. 0.81859. So we're going to go 0.86. All right, 8186. All right. So right there. So then, you know, I don't know, some of y'all might convert this, all right, and go 2.28%. All right, you can go 0.00, 0.13%. All right, and 15.73%. All right, and 81.86%. All right, so same thing, just in parentheses. All right, man. So I'm just gonna go through this and identify the parts real quick. All right. You should know how to put this in your calculator by now. All right. I'm just gonna identify your parts, and you calculate it. All right, I'll write the answer for you, but make sure you know how to calculate this, okay? All right, for this first one here, the probability that x is at least, all right, at least 360 means this is the minimum. All right, that's your lower bound. All right, lower bound. So when you do that one, you're going to get, and don't forget normal CDF. All right, and you're going to have lower bound 360, upper bound. Make sure you pick something significantly higher. All right, something like 1,000, 10,000. You pick. All right, you pick. Don't be afraid to pick something higher. All right. What's the mean? 350. All right, and then standard deviation of 54. Okay, and that's how you would do it, guys. All right, like that. Put that in your calculator. All right, when you do that, you get 0.4265. All right, there you go, right there. All right. All right, for this one right here, it says probability. I'm sorry, we gotta do this one. The probability that you have no more than. All right, no more than means this is the max, 295. All right, no more than 295. So go ahead and put that in. All right, you put that in. You have norm CDF of pick a number less. All right, so I'm gonna go negative 1,000. All right, you pick a number. All right, 295, 350, and 54. All right, 54. When you do that, you get. All right, when you do that, again, you're going to get 0.1542. All right, or you can say 15.42%. All right, I just like, guys, I like 4 decimal places on everything, and that's just me. All right, for this one, all right, you're going to get, here, let me make this a little bigger so I have more space to write. All right, this one, you're going to have normal CDF. All right, between, so lower bound 300, upper bound 400. All right, and again 350 and 54. All right, put that in. All right, let's see what you get. All right, you're going to get 0.6455. All right, 55. All right, or 64.55%. Okay. All right, listen, man. These right here are the exact same thing. It's just in notation. So look, I'm just going to indicate what's what. All right, you practice it. I don't want to make the video too long by working through all these. All right, this one right here, all right, x is less than this, which means this is your upper bound. All right, and when you do that one, you're going to get 0.6783. All right, or you can put 67.83. All right, not 0.8. Sorry, guys. All right, look, again, right here, make sure you pick a number, all right, that is less than 375. Like I pick a negative 100. All right, doesn't matter. All right, just pick a number. See, here you have a lower bound and upper bound. Here you got to make it up. All right, so just pick a number that's significantly less. All right, here, pick a number that's significantly more. Like I would go 1,000 right there. All right, just to be on the safe side. All right, pick a number that's a little higher. All right, so anyway, when you do this one, that's your lower bound. So 389. All right, and when you do this one, all right, your answer should be 0.2351. All right, when you do this next one, you should have all right, you're going to have lower bound and upper bound. And when you do this one, it will give you 0.4831. All right, convert that to a percent, 48.31. All right, this one, lower bound, upper bound, and it will give you 0.1138. All right, or you can put 11.38%. All right, your choice, okay? All right, that's that. Number 10, man, let's go over number 10. It says the heights of 24 children are on a merry-go-round in a park are given if the mean of all the children in the park was 45 inches and the standard deviation is 6, does the data appear to be normally distributed? Explain. All right, well, look, listen. All you do, guys, right here is take the mean of 45 inches. Now, here's what we're going to do. We're going to count how many students or how many kids are below 45. All right, so 1, all right, I see 1 kid. All right, did I overlook it? Nope, 1 kid is below 45. All right, just 1 stinking kid. All right, so below, all right, below 45, 1 kid. All right, which means above 45. All right, I should have, if it's 24 kids, it should be 23. But I'm just going to do this to be on the safe side. I know some of you guys are thinking, well, what if it's 45? Yeah, what if it is 45? Guys, that doesn't affect the mean in any type of way. All right, that doesn't change the bell curve. I don't know why this isn't changing. Let's see. All right, there we go. So again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 18, 19, 20, 21. 21 kids. All right, 21 kids. All right, above 45 is 21 kids. All right, so now your conclusion, guys, is not a tough situation, man. What you got to do is just explain that. All right, is this normal? No, it's not. It's not normally distributed. All right, not normal. All right, it's not a normal distribution or distributed. All right, and again, the reason being is because, look at it, it's 21 kids on one side. All right, there's way too many kids on one side. All right, it's not going to give you a normal bell curve. It's going to give you something skewed like this. All right, skewed to the left. That's where the tail is, to the left, so skewed to the left. All right, another example, man, same type problem. All right, there is 30 randomly chosen apples from a large bin. The mean weight is 110 grams and standard deviation is 5.5. All right, does this appear to be a normal distribution? All right, so again, the standard is 110. All right, 110. So let's see how many are above 110, or let's say below 110. So below, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All right. So 13 or below, right? Yes, 13 or below. All right. I see those. All right. But anyway, we're looking at above and below. Okay. So 13 or below. Oh, shoot. Change back. There we go. 13 or below. Ooh, it's not changing back. Hold on. All right, there we go. 13 below, right? So 13 or below, then let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And 13 above. 13 below, 13 above. 110. All right. So this is, all right, a normal distribution. All right, normal distribution, because it'll give us a normal bell curve. All right, with 110 in the middle for the mean. All right, so this is good. All right, this is a good distribution. All right. Anyway, man, let's go ahead and move on to the next one. Number 14, find the expected value of 6 die given die with the given sides. All right, so here we go. Let's go ahead and dig in, man. For die, remember die is 1/6. All right, so 2. All right, you have 1/6. All right, because there's only 1, 2 up there. All right, for the 4, all right, you have 2 4s, so 2 out of 6. All right, plus 6. All right, how many 6s are there? 2 6s. All right, so 2 out of 6. All right, plus 8. Man, yo, realistically, I don't like that 8 being here because you can't roll an 8 on a die. You know what I'm saying? All right, but for the sake of doing this, there's 1 8, so we'll go 1 out of 6, okay? It should be like a 5 or something, not an 8. But anyway, we're going to say it's an 8, all right, somehow mysteriously on a die. You multiply this, all right, which gives you 2, 6, all right, plus 8, 6, all right. You guys know you just multiply to the top. 2 times 1 is 2, 4 times 2 is 8, 6 times 2 is 12, all right, and 8 times 1 is 8. All right. And anyway, when you add all that up, you get 10, that's 20, that's 30. All right. So 30 over 6 is 5. All right. The expected value, guys, is 5. All right. You can do that in your calculator. Your calculator will do all that for you. All right. All right, guys, there are 40 stones in this bag. All right. There are 15 rubies out of 40. All right. And then there are 12 sapphires out of 40. All right. And then there are 13 emeralds out of 40. All right. Now let's look at the price. All right. Each ruby is $8. All right. Each sapphire is $6. All right. And each emerald is $10. Okay, $10. So anyway, when we do that, guys, all right, again, throw it all in your calculator, man. You're going to end up with $8.05. So that is the expected value of picking a stone from the bag. Okay, the expected value is you're gonna spend $8.05. All right. This problem here, come on. All right, so it's in high school, the average amount of time the students sleep each night was 7 hours, and the standard deviation is 7.75 hours. All right. Use this graph to estimate the probability that a randomly selected student spend more than 6.25 hours sleeping a night. All right, so check this out. In the middle, guys, that's 7. All right, that's 7. All right. They said the standard deviation is 0.75. So if I go 7 minus 0.75, that gives me 0.25. That's one standard deviation right there. All right. So the question says, estimate the probability that a randomly selected student, all right, sleeps more than 6.25 hours. All right. So more than will be this way, all of this, right? More than. Now, I'm shading this, all right, but let me show you, man. You can do this in your calculator. All right, not the graph, but solve this. All right. If you want to solve this in your calculator, here's what you do. All right. We know that this is 7. All right. The standard deviation is 0.75. So if I subtract 0.75, that means that this is the minimum. All right. This is the minimum or lower bound. All right. That's your lower bound. Excuse me. So now that I know that, I can put this in my calculator. Here's what I mean. All right. I'm going to have the normal CDF. All right. And I'll have my lower bound. All right. Of 6.25. All right. My upper bound, let's just say 12 hours. All right. Because we're talking about sleeping. So we're not going to put like 100 hours, 300 hours. We're talking about 12 hours. All right. Or heck, let's just put 24 hours since it's a day. All right. 24 hours. I'll use that. 24 hours, okay? And then the mean is 7, and the standard deviation is 0.75. All right, so we're going to use our calculator like that. So when I go to the calculator, and I go second and VARS and option 2, all right, our lower bound is going to be 6.25. Upper bound, let's just go 24 hours because it's 24 hours in a day. The mean was 7, and the standard deviation is 0.75. All right, so it should look like that. And when we hit enter, all right, here, let me clear this off so y'all can see the one problem that we're working on. There we go. All right, you get 0.8413. All right, or basically 84.13%, all right, of the selected students get more than 6.2 hours of sleep. All right, that's basically what that means, okay? All right, let's look at this one. Oh, yeah, okay, good problem right here. Let's dig in. All right, man, right here, man, Jack can have 3 routes to work each day. All right, route 8 takes 16 minutes. All right, 16 minutes. Guys, I always put the parentheses right here. All right, because I know I'm going to need them. All right, so route A, I'm just going to look at route A. All right, route A takes 16 minutes, route B takes 10 minutes, route C takes 20 minutes. All right, there's a 40% chance that they will encounter an accident on route A, all right, which increases the travel time to 25 minutes. So y'all see this bit of information right here, 40%, all right, 40% chance that I'll have an accident, which will cost 25 minutes. All right, it'll cost me to take 25 minutes to get there. All right, there's a 40% chance that it'll take me 25 minutes to get there. So remember, everything must equal 100%. All right, so if this is 40%, then this is 0.6 or 60%. 40 plus 60 is 100. All right, so I'm going to do this equation right here. 16 times 0.6 plus 25 times 0.4. When I do that, I get 19.60 minutes, all right, or 19.6 minutes, okay? All right, for part B, remember B took 10 minutes, all right? B took 10 minutes right here, all right? But there is a 20% chance I will encounter a traffic jam on route B, which will increase the travel time to 40 minutes. So a 20% chance it'll take me 40 minutes. So again, it took 10 minutes, all right? But I know that there's a traffic jam, all right, that's going to cost me 40 minutes, and there's a 20% chance of that. So again, you got to have 100%, right? So 100 minus 20 is 80. All right, so here's my equation. All right, so I have this right here, 10 times 0.8 plus 40 times 0.2, and that's going to give me 16 minutes. All right, and lastly, part C. All right, C will normally take 20 minutes. All right, but there's a 10% chance that there's a delay on route C, which increases to 32 minutes. All right, so normally it's 20 minutes. All right, but there's a traffic jam that's going to make me take 32 minutes, and it's a 10% chance, 0.10. All right, so that means out of 100%, all right, 100 minus 10 is 90. All right, 90% chance that it'll only take me 20. And when I do that, I get 21.2 minutes, okay? So, anyway, after doing all that, guys, which route is faster? This one right here. All right, this is the fastest route, 16 minutes. So the route we would take is route B. All right, route B, okay? Man, that's it. I hope this helps, man. I wish you the best. All right, yo, if it does, hey, make sure you give me a like and make sure you subscribe so you can get these notifications directly to you, okay? All right, good luck.